So, hi everybody, welcome to our next session of the 2021 Virtual Vanderbilt Summer Science Academy. It is awesome to see you here, and we're excited for our next set of speakers today. So today's Monday, so we're focusing on the PhD track, as you know. And today we have some older graduate students who are going to be talking about their journeys. The first one we have up is Emilio Rivera, who I know very well. It's great to see you, Emilio. Thanks for being here. And whenever you're ready, Emilio, you could share your screen and get going. Thanks for doing this.
Sounds great. Well, thanks for the introduction, Beth. As Beth said, my name is Emilio Rivera, and I am a rising fourth-year graduate student, which is mind-boggling. Time flies when you're having fun, I guess. So I'm going to try to share my screen, and hopefully you all can see the right thing here. Great. So I'm going to tell you a little bit about my journey, how I got to grad school, what grad school's been like since I've been here. And you know, feel free to interrupt me with questions if you've got them while I'm talking, or if you want to wait till the end, that's fine too. So with that, I guess I'll go ahead and get started. So first of all, who am I? As a scientist, and I think for the most part in any profession, you have kind of two veins that belong or that contribute towards the answer to that question. Right? Who are you personally and who are you professionally? So personally, my name is Emilio Sanchez Rivera. I'm of Hispanic descent. I'm of Mexican descent. I was born and raised in Las Cruces, New Mexico, a little town not too far from El Paso, Texas, like 50 miles from the Mexican border. And so culturally, I grew up in a very Hispanic place, speaking Spanish in the house, that sort of thing. I have two older brothers and three younger sisters, and some of that will kind of come into play moving forward. And then on a professional level, I'm a rising fourth-year student, as I said. That's still like that number 4. I wrote it down there. Oh, goodness. How did that happen? But here we are, rising fourth-year graduate student. I'm in the lab of Richard Caprioli, so he is my advisor. He drives a lot of the science that goes on here, and I report to him. And my research is at the interface between chemical instrument development and microbiology, and I'll talk more about what I mean about those things, and you'll start to see kind of in the latter half of this little talk. So how it all started. Here's a picture. I was telling Beth before we started this talk that I actually called my mom and asked her to go through some pictures and things, and so she was just as excited about this talk as I think I was. So here we are, my dad, my mom, my two older brothers, and me. I said they were older. I didn't say how much older. My oldest brother is 18 years older than I am, and then the middle brother is 15 years older than I am. And so my mom, when she sent me this picture, said, "No wonder you always felt like you had 3 fathers." I really did. So you can imagine that my dad obviously had a huge impact on me, but my older brothers certainly did too. My dad is an MD, and so as you can imagine, growing up in that house, I got to hear him on the phone or hear him talking to friends or whatever about what it was like to be in the operating room. He's an anesthesiologist, and so there I am in my own little pair of scrubs, and so growing up from that age on, MD was it. I wanted to be a doctor. That was pretty easy for me to know, or at least I thought it was. Another component of this story is that the middle brother, Raul, who was on the left in that other picture, also got his PhD. So I was in middle school when he graduated. Here he is at Arizona State. And all through his journey, you can imagine that played a pretty significant role in my interests. So he was in Phoenix, about a 5-hour drive from my hometown, Las Cruces, and we would talk on the phone all the time. I remember I was in like 2nd grade or something, and I called him and I asked him, you know, if you take water and you put it in a water bottle and seal it so it's vacuum tight, and then you put it out in the desert, will it evaporate? And I couldn't tell. I couldn't decide what I thought the answer was. But my mind was always geared towards science anyways. And so when he got this message, I had to leave him a message. He was enthralled. And so ever since then, he's been a huge part of helping me to decide what it is that I wanted to do. And so I'm very grateful for him. And kind of a part of that too, this is his first lab at New Mexico State University when he was an undergrad. So I was like 3 or 4 years old and he's walking me around this lab. And so being in the laboratory was not uncommon for me. It started at a pretty early age, but even then, you know, MD all the way. Like I wanted to be a doctor like my dad. So I went to high school at Las Cruces High, and what a lot of people don't know about me actually is that I was in broadcast. And I found a passion for filming sports. So I love to film, especially football. It was a lot of fun. So I was always on the sidelines of all the games and filming and trying to get the best shots that I could. And that was a lot of fun. And so for a period while I was in high school, I actually kind of deterred away from the MD track and decided that I might want to go to USC to pursue a career in media at the School of Cinematic Arts. But you know, my true love from the very beginning for that MD was enough to keep me in that track, I guess. And so I went to New Mexico State University and I majored in biochemistry. Again, MD all the way, and statistically at the time, biochem was the most successful or the gave you the highest likelihood of being accepted to a medical school. And I thought, okay, well, biochem it is. So to sort of boost my resume, a friend told me, well, you know, you should probably start doing some research. It'll look good. So I went and talked to this professor, Dr. Antonio Lara, and here's a picture of him. I started researching his lab as a freshman in college, and the whole reason that I was there was just to boost my resume. I thought, okay, well, whatever I got to do to get into med school, that's what I'm going to do. And so, like I said, I started working in his lab, and that really didn't go as planned at all. This man changed my life in ways that I can't even really explain. So the science that we were doing was all revolved around soil chemistry. So what I'm showing you here is actually some soil, different kinds of soil from different parts of the United States. And then we would make these pellets out of them. We would actually bake them or frit them. And the reason that we were doing this is because we were interested in trying to use this soil for environmental chemistry applications. It turns out that soil is actually really good at cleaning up water from like heavy metals and things. And so Dr. Lada's lab was really focused on trying to understand how we can use soil to clean drinking water for the Navajo Nation. A lot of wells in drinking wells in the Navajo Nation have a lot of heavy metals, in particular uranium. And so we were trying to help them. That was what everything was focused on in his lab. And so I fell in love with this idea of doing science for something meaningful, for something that can help people. And then these other pictures here are actually from a mine spill into the Animas River in Colorado. And we went and sampled this and analyzed it and found all sorts of interesting things. And so, again, this was a part of my life that I'd never anticipated kind of taking over in a way. So there's Dr. Lada again. And while I was in his lab, he taught me a couple of really important things. One, first and foremost, research should help people. And this was something that he believed with every fiber of his being. And that really struck me because that was why I wanted to be an MD in the first place. Why I wanted to be a doctor was to help people, because that's what I thought my dad was doing, which he was. I didn't realize at the time that science could do that too. He also taught me that analytical chemistry can be cool. So cool that he inadvertently helped me change my mind. And I realized that a PhD was really where I wanted to be, was really more of where I belonged than an MD. I can help people in that way too. And then the last thing he taught me that I try to keep sight of now, and it can be difficult, is to work hard, but to never lose sight of the other things in life that matter. Science is great, work is great, being in the lab is great. But there are things out there that you need to focus on and attend to, and never lose sight of those things. So I decided, okay, I want a PhD. I don't know how I'm going to get it. I don't know where I'm going to get it. Life's funny that way, but I know I want it. So speaking of things that matter outside of science, while I was at New Mexico State, I also met my now wife, Lindsay. And this is her at her white coat ceremony here at Vanderbilt. So while we were at New Mexico State, she decided she was going to grad school at Vanderbilt. And I thought, okay, well, I got to keep sight of what's important, right? So I'm going to follow it. So she comes to Vanderbilt, and I emailed Beth because Beth had been so helpful to Lindsay. And so Beth helped me get in contact with a couple of people here at Vanderbilt. And I was lucky enough to get a job here working in the Mass Strat Corps under Dr. Kevin Shai and Dr. Wade Kelkin. And so they kind of took a chance on me. I was fresh out of college, but they decided to hire me. And so for 2 years, while Lindsay was in the first couple of years of her grad program, I got to work for these great guys. And they taught me a whole nother component of science that I wasn't expecting. I came from New Mexico State, where everything was all about passion for helping people and for what the application was. And what my time in the Corps taught me some really important things about the impact of your science. The more impactful your science can be, the more potential it has to help people. And so I learned a lot of other skills from these two guys, and plenty of others during my time there, and I'm very grateful for them. And so then after 2 years, I thought, okay, well, like I said, I know I want my PhD. Maybe I can get it at Vanderbilt. And so I applied, and sure enough, I was lucky enough to be accepted. And so here I am at my white coat 2 years after Lindsay's. And so, the dream is almost there, right? Like, decided I wanted a PhD. Here I am starting the program. So now that I'm in grad school, I've decided to join, or I did decide to join Richard Caprioli's lab. We are focused on mass spectrometry, and I'll talk a little bit more about what that means in a minute. But this is our lab. This is actually a bit of this is a pre-COVID picture, so we've had a few changes since then. But we're a big happy family, and I found a lot of the same kinds of love and passion here that I had at New Mexico State, and that was a big part of what I was after. And so I thought long and hard about some of the things that really matter to me since I've been in grad school. And the first one that came to mind is that I get to drive my own research, and that's kind of what's cool about a PhD, is that you, within a certain realm, you get to decide what you're doing. You get to decide what experiments you're running and what science you're doing. And going back to Dr. Lotta's point, there's plenty of potential to help people with the work that I've chosen to do, and that definitely makes it easy to get out of bed in the morning. I also have the flexibility to attend live outside of grad school. So again, going back to what he said, I've got time to do the things that I need to do. So, Lindsay and I have a house. We've got a couple of dogs that we love very much, and so it's not all lab. I get to do a lot of the things that I love outside the lab, and grad school affords me that flexibility. And then the last thing is that I'm encouraged to be myself. I mentioned earlier, I'm Hispanic, and that's a very important component to who I am. And being in this lab, being at Vanderbilt, has really allowed for me for that to be a part of who I am, and it continues to do that every day. So I'm very grateful for that. So kind of shifting gears here a little bit to what it's been like since I've been in grad school. So everybody talks about their thesis project, right? What do you do for your PhD? So what our lab focuses on is particularly a technique called imaging mass spectrometry. And so kind of at its fundamental level, what this means is that we can take tissues like a brain seen here, or any other kind of organ, and we can section that into really thin slices. And then we can put that onto a microscope slide. Sorry, my mouse is kind of slow. Put that onto a microscope slide. And then we put this small organic molecule on it called a matrix, and that just helps for the process to go along. So then once we're done with that, we can put that into our instrument. And what we actually do is fire a laser at it. And what we do is we fire a laser at it in discrete points across the entire section. So every point along this section is going to get hit by a laser. And when we do hit it with a laser, then the molecules that are there can be sent into the mass spectrometer and analyzed. And so for every molecule that we detect, we get one of these peaks. And so what's really cool is we can generate images like this. So in this kidney, this is a rat kidney, what we've done is we fired a laser across in discrete points across this entire kidney. And then at the end, we get this spectrum. So each one of these lines, each one of these peaks is a molecule that we detect. And then at the end, I can say, okay, computer, I want to see this molecule. Where is this molecule? And so then the computer will plot it in space and say, okay, well, that particular molecule really only localizes in this region of the kidney. And then these two other molecules localize in different regions of the kidney. And so this, you can imagine, is really powerful for trying to understand what molecules play what roles in different organs. And then if you bring in the idea of disease, what's different from normal? How did these molecules move around? You can start to get at a lot of really important biological questions. So this is Dr. Spraggins, or Jeff. He is kind of my daily mentor. And so when I joined the lab, Jeff said, okay, well, I've got this idea. I don't know if it's going to work, but we'll give it a shot. So I just wrote this grant for this instrument. It's called the timsTOF. And I want you to use this thing, and I want you to analyze these other things. They're called glycans, and I didn't even know what a glycan was. They're just like strings of sugars. And they're really complicated to analyze, but I think you can do it. And so I think that this instrument will help you analyze these analytes, these molecules, and then you'll be able to tell where they are in different organs. And I thought, okay, well, that sounds fun. So, you know, I gave it the old college try, and it was starting to work. But ultimately, it wasn't working well enough. And so project number one kind of didn't pan out, and that's okay. There's plenty of other things to go around, right? So project number two, Jeff said, okay, well, there's this technique that we're looking at trying, and I want to give it a shot. I want you to put it on that instrument that I wrote a grant. Okay, cool. So I told you about this process called MALDI, where we fire the laser. There's a sample down here. What I didn't tell you is that when the MALDI laser hits that sample, it creates what we call a plume, shown here in purple. That plume has all of the molecules that we're interested in detecting before they get taken into the mass spectrometer. Well, there's this new technique called MALDI-2, and basically all it means is I'm firing a second laser. So I take a whole nother laser and I fire into that plume. And then what that allows for me to do is detect a lot more stuff, a lot more molecules, shown here in blue, than I would detect without it, shown here in red. So we're going to see a lot more molecules that we might be interested in seeing. So I did. You know, this is a whole nother component of what I've done. This is the second laser that I stuck on to this table, and we've got a couple of mirrors that you can see. And so now I've changed the trajectory of this laser, and it can now fire into this MALDI plume and increase the sensitivity of these molecules. And so that's all well and good, but it's not exactly a thesis, you know. So now I've got to figure out exactly what's the next step. So the one that stuck, right? The project that everything is kind of revolved around wasn't even anyone's idea, really. So this is Dr. Eric Scar. This is my favorite picture of him. And he actually does a lot of collaboration with our lab. And so Dr. Caprioli and Dr. Scar have a great relationship. And so a lot of our research kind of focuses on Dr. Scar's research, which is microbiology. He's a bacteriologist, and so he works with a lot of different pathogens, a lot of different bacteria, in particular Staph aureus, so what causes staph infections. So Dr. Scar has a postdoc in his lab named Andy, and Andy and a grad student at the time, Will, in my lab, worked together. And so one day I'm in the lab, and Andy walks in with this box of samples and hands them to Will and says, "Here you go, Will." And Will goes, "Oh man, I forgot that was coming." So then Will kind of looked around, and so Jeff, who I told you about earlier, was in the corner. And so Will goes over to talk to Jeff and says, "Hey, Andy brought me these samples, but I really don't have time to do this. Who else could do this?" And Jeff goes, "I don't know. Emilio, why don't you do it?" All right. So what Andy had brought over were staph biofilms. So what Andy had done, Andy's a really talented bacteriologist. And so what you're looking at here, they look like little fried eggs. This is a Petri dish, and it's got some media in it. And then this is a disc filter. That's not really important. But then this yellow thing is actually a biofilm of bacteria that are grown by Andy. And so then what we're really interested in is understanding how different molecules might localize to different regions in this biofilm. So it kind of grows kind of cool. And so nobody had thought about doing this. It really wasn't even somebody on anybody's radar. But I've since sort of tried to develop a thesis out of it. And so I've come up with this whole workflow for how to work with these things and how to get something meaningful out of them. I won't bore you with the details, but I had to start from scratch. This wasn't anyone's idea. This was just something that got thrown in my lap, almost literally, and it's become my thesis. And so I can take these biofilms, and I've now found that they really do have very different localizations of different molecules. And this has never been seen before, so I'm really excited about it. Each one of these colors represents a unique molecule. And so no one expected for them to have such distinct localizations within these biofilms. And I've been able to do this over the course of the last year or so. And so this is, like I said, this is what my thesis has become, and no one really expected that. And I think that's kind of cool. That's to me, that's part of what makes a PhD so interesting, is you never really know what's going to come through the door, but it could change your life. So just one last little thing here. Yeah, same sort of thing. All of these molecules, it's not really important what they are, but each of these has a bunch of carbons on them. And what's crazy is that if you add or subtract just one carbon, they have different localizations. And again, no one's really expected this at all, and I can't understand it. I'm trying. But it's been a lot of fun to find these things, to make these observations, and to try to wrap a PhD around it. So, anyways, I hope that's been at least, if nothing else, entertaining to listen to. I've got plenty of people to thank. This is part of being, I'm in a big lab, so everybody listed here is in the Caprioli lab. There are a lot of us, and it's a lot of fun. Like I said, we're really a big, happy family, and getting a PhD so far, at least, has been a great experience. An experience that I wouldn't trade for anything. So, anyways, I think hopefully I'm right on time, give or take. And with that, I'll take any questions. Thanks for listening.
Wow, Emilio, thank you so much. That is just awesome to hear your journey and to hear about, sometimes scientific projects, they can be described as like this very methodical, develop your thesis and your hypothesis and test it out. And well, not always. So that's a great demonstration. Appreciate
Exactly,
that.
yeah. Thank you.
All right, let's open it up. Any questions for Emilio about his journey, about his decisions, or about his science? I've got a question, and I'm sure others will come. How did your family feel? I mean, it sounds your brother got his PhD before you, but how was that navigating those discussions? If your dad was an MD and likely your family thought that's what you guys might do, how was that navigating that discussion?
Yeah, that's a great question. So neither of my parents were ever pushy about getting an MD, which I'm grateful for. Obviously they hoped for great things, but I never felt like I was letting them down by changing my mind. Now, it depended, right? My dad always said, "I'm going to support you no matter what you decide to do, so long as it's worth doing," right? So don't go be a bum, don't whatever. But it didn't matter to him, and that meant anything. If I could have been an electrician, I could have been a plumber, I could have been anything, and my parents would have supported me in that decision. So it was good to know that. It was good having that feeling.
Great, thank you. What about, sorry, this is always an interesting point for me. What about for yourself? Did you kind of have a internal debate, or was that making that switch? How was that for you, switching from MD to PhD?
It was slow. It was slow. I mean, it there are still moments that make me think maybe, just maybe, I should still try to go get an MD. Um, I I was always attracted to that life, and I'm very satisfied with what I've chosen, and I think I made the right choice. But there is always going to be that part of me that thinks, well, maybe I can do that too. But ultimately, like I said, I'm pretty satisfied with my decision. I think maybe there was something in the chat.
Yes, thank you so much. Oh, yes, wonderful questions here. I'll read it out loud because we are recording this for other people to hear too. Any advice for undergrad students regarding what to look for lab rotations? I'm guessing in grad school.
Sure, yeah. So lab rotations for grad school. The one thing that actually Lindsay told me before I started grad school, and I thought it was great advice, is choose an advisor, not a lab. Excuse me. So the picture that I showed you, half of those people are gone, and I love them dearly, and I always will, but they're gone, right? So the dynamic of the lab isn't today what it was then, and that's not necessarily a bad thing. But had I chosen the lab based on the people that were here, I would have been in for a rude awakening. So choose an advisor, choose the science or the type of science, and but don't focus too much on the people that are there at the time.
It's a great point. My lab went from 10 people when I first joined to 2 people when I graduated. It had changed a lot, and nobody anticipated that happening.
And it's crazy how fast it can happen too.
It does. It feels like it's going to be there forever, but it's not. Grad school goes by fast in general.
Yeah.
What about what's been one of the biggest challenges you've faced in grad school, or maybe even an unexpected challenge?
Yeah. So for me, by far the biggest challenge has been staying focused. And I'm sure it's probably obvious to all of you that I tend to get pretty passionate. I tend to fall in love pretty easily with just about anything I'm doing. And so my problem is that there's too many cool things going on, which is a good problem to have. But I tend to lose sight of what I really should be prioritizing. And so that's kind of actually a word of advice that I would give to all of you is if you are anything like me, prepare to buckle up and do what you got to do, right? You gotta get things done. And that's by far been the biggest challenge for me.
Wow, thanks for saying that. That was totally me. I just, everything was cool and exciting, and I had to do it right now instead of sometimes there's things to maybe focus on a little bit more and to that some things you can put aside or help somebody else do. That's awesome.
Exactly.
I had a question here. Have you considered going back to environmental analytical chemistry at all?
I definitely have. And part of what I am trying to get out of grad school, and so far I feel that I've been successful, is making myself as well-rounded as I can be. So I've sort of committed my life to working in mass spectrometry. That's what I'll hopefully do for the rest of my life. But the nice thing about mass spec is that it's very diverse. It's very versatile, and so it's heavily used in environmental chemistry. It's heavily used in all sorts of different fields. And so what I'm trying to do now is make sure that I'm prepared to do any of those things. And yeah, absolutely. If an opportunity were to arise after grad school where I could take what I've learned here and apply it towards environmental chemistry, absolutely, I would consider that.
Sounds like you're pretty open-minded about the next step.
I am. Yeah, I've been a little bit all over the place in terms of deciding what I want to do next. But I try to be as open-minded about things as I can.
Very cool. I think we got one last question. How intense is the academic rigor in a PhD? And how did you cope with stressful classes?
Yeah, that's a good question. So, at least at Vanderbilt, the academic rigor really doesn't come as much from your classes. So the way it was for us is you take classes usually for the first 2 years or so of grad school. And those classes can be tough. Don't get me wrong. I'm not saying they're easy. I'm not saying they're a breeze, but I think everyone is kind of under the general understanding that that's not the focus of why we're here. So really what it's about is the research, and really what it's about is trying to make something out of what you've been given. And so for me, the stress really didn't revolve around classes too much. I knew that I just had to get through them, and that kind of brought me some solace. But where the real stress has come from is like I said, trying to make something out of what I've been given. So Andy walked through the door with some biofilms that I'd never heard of, and I had to like weave a PhD out of that. And it's been fun, but it can be stressful because nobody's in charge of it but me. So if things go awry, I ain't got nobody to blame but me, which can be stressful, but it's also fun. And I think that's maybe what makes a PhD what it is.
I completely agree with you. And I think that one of the ways to look at grad school is, and that kind of stress is, it's a marathon, not a sprint. So your focus on living life outside is a very important aspect. So
Yeah.
thank you. Thank you so much, Amelia. Thank you, everybody, for being here. And we'll see you at the next one. Bye.
Check out our website to find recordings of all of our videos. We'll get them posted about a week after each of the presentations. We can't wait to see you.